Okay, welcome back. This is Mr. Hassan's Maths channel, and this is a question from one of my end of topic worksheets that a student has asked me to answer. This is from the P4 syllabus, from the old Solomon D papers. The Solomon papers, this is Solomon paper D, and this is question number 7 from that paper, and question 2 for my end of topic worksheet on parametric equations, which is related to chapter 3 and also the chapter 5 on differentiation as well. It's related to both of those chapters in P4. Now this question here is about, as we said, parametric equations, and it's first of all telling us to show that dy dx equals minus 2/3 of cotangent of 2t, given that x equals 3 cosine squared t and y equals sine of 2t, and they told us that the values of t are between 0 included up to but not including pi. Now in this question we want to find dy dx, but we want to find dy dx in terms of t, and x and y are both given in terms of t. So as we want to find dy dx in terms of t, then really what we need to do is we need to differentiate this using the chain rule, so our answer will be in terms of t. Okay, normally when you get a parametric equation, that's the easiest way to find dy dx, but your answer will be always, of course, in terms of t then. Okay, because you differentiate x and y both with respect to t, your answer will be in terms of t, which this is the case here. So what we need to do first is we need to use the chain rule. The chain rule is such that if you want to find dy dx and y and x are both in terms of a third parameter, in this case t, then you find dy dt and you multiply that by dt dx, which is the reciprocal of dx dt. Okay, and then that will give you dy dx, but in terms of t. So what we're going to do first is we're going to find dy dt and find dx dt, and then multiply dy dt by the reciprocal of dx dt, and we'll get dy dx. So let's find out now what dy, let's start with y. We say y is equal to the sine of 2 times t, the sine of the angle 2t. Okay, so we want to find dy dt. Now that's pretty simple. We know that the main function here is the sine of something. Okay, the main function is the sine of something, which becomes, when you differentiate, the cosine of the same thing, but then you have to multiply by the differential of what's inside the function. If you differentiate 2t, you get 2, so it's 2 times the cosine of 2t. So that's dy dt. And we know that x equals 3 times cosine squared t. Now, cosine squared t is the same as saying cosine of t all squared. All right, cosine squared t is the same as cosine t all squared. Now what that is, what that means is this function here is basically the main function here is something raised to the power of 2. So when you differentiate something raised to the power of 2, what you do is you multiply by the power, so you have 6 times, and then you leave this the same, but you take 1 from the power, so that becomes 6 times cosine t to the power of 1. Then you multiply that by the differential of what's inside the function. Now the differential of cosine t is negative sine t. Okay, so you end up with dx dt being negative 6 sine t times cosine t. That's dx dt. Now we can see our answer has to be in terms of a double angle, cotangent of 2t, and this is already in terms of a double angle, dy dt. This is in terms of a single angle, so obviously we have to try to make this in terms of a double angle, so we have to think about the double angle formulae. All right, and the double angle formulae are basically for sine is the sine of 2t would be equivalent to 2 sine t cosine t. Okay, that's the formula that you must know. That formula is not given in the formula book. It's derived from the formula in the formula book. Sine a plus b is equal to sine a cosine b plus sine b cosine a. Or you could say cosine a sine b, same thing, right? Basically the sine of one angle times the cosine of the other, plus the sine of the other angle plus the cosine of the other. Now, if a and b are both the same, if they're both a, for example, that would be sine a plus a, which is sine of 2a, and that would be sine a cosine a plus sine a cosine a, which would be 2 sine a cosine a. So that's where this formula comes from. If you didn't know this formula, this is in the formula book, this isn't. So you have to know this formula. After a little bit of practice, it'll be stuck in your head anyway, but that's where it comes from. It comes from the double angle formula. So the sine of 2t is the same as 2 sine t cosine t. So if I want to go this way, okay, then I can say that whatever the coefficient is here, I have to take half of it, okay, and whatever the angle is here has to be doubled, all right? So basically, what I can do here is I can take a half of the coefficient and double the angle, all right? Or you can think of it like this if you want. You can say, okay, I got minus 3 times 2 sine t cosine t, and 2 sine t cosine t is the same as sine 2t. That's going to give you minus 3 times sine of 2t. So whether you think about it as take half of the coefficient and then double the angle, or you're thinking of just rewriting this as minus 3 times 2 sine t cosine t, you end up with negative 3 sine 2t. That is what dx dt is. Now, we can now find dy dx because we know dy dt, which is cosine 2t, sorry, 2 times the cosine of 2t. And we know that dt dx is the reciprocal of this. That's times 1 over negative 3 sine of 2t. All right, so when you put that together, you have 2 cosine of 2t over negative 3 sine of 2t. And we know that the cosine of an angle divided by the sine of the same angle is equal to the cotangent of that same angle. So this is minus 2 over 3 times the cotangent of 2t. And that's what we had to show. dy dx is equal to that. That's exactly what we see there. So there's part A done using the double angle formulae and some differentiation of trig functions. So there's part A completed. Now for part B. It says find the coordinates of the points where the tangent to the curve is parallel to the x-axis. So now, first of all, supposing you didn't know how to show part A. Okay, supposing you didn't know how to do this. It doesn't mean you give up the whole question. Right? That's 4 marks. Here we have another 3 marks. And other parts you might even be able to do. They've told you what the differentiation is. They've told you what this is. And when you differentiate something, as we know, it's a gradient function. So you don't actually have to be able to show part A in order to use part A to answer part B. We can use the answer they already told us for dy dx and what we know from the equation that they told us to answer part B. So don't give up on a question if you can't do the first part of it. Look at the other parts of it and see, does it depend on the first part of the question? In this case, it doesn't. So you can just go ahead and start answering it without even knowing how to do part A if that was the case. Now it says, find the coordinates of the points where the tangent to the curve is parallel to the x-axis. Okay, so now what we need to do here is we need to find what is called the gradient. Okay, the tangent, the points where the tangent is parallel to the x-axis. Okay, when it's parallel to the x-axis, now we know the x-axis is basically the horizontal axis, right? This is the y-axis and this is the x-axis. So if something's parallel to the x-axis, that means its gradient is equal to 0. So we know the gradient of something which is parallel to the x-axis is equal to 0. So basically what they're asking us to find the coordinates of the points where the tangent of this curve is equal to 0. So that's when dy dx is equal to 0. Okay, so we got minus 2 over 3 times the cotangent of 2t is equal to 0. That's what we got to find. Okay, that's what we have to find. So now let's solve that equation. Okay, let's solve that equation. So we can basically, we can divide both sides by minus 2/3, or multiply by 3, divide by minus 2 if you want. That will be cotangent of 2t is equal to 0. So we got to find where this is true. Now, the cotangent of 2t is equal to 0. Now remember, the cotangent is the reciprocal of the tan curve. Okay, and the cotangent curve equals 0 where the tan curve is undefined. Because if you try to write this as the reciprocal, this will be the tan of 2t is, if you do the reciprocal of 0 over 1, you get 1 over 0. This is undefined. Okay, so we got to find where the tan curve is undefined in the range of values between 0 and pi. For t values between 0 and, in fact, 2 pi. okay, up to 2 pi, because you have to change the limits according to this. This is t, so you have 0 is less than or equal to t, which is less than pi. So we got to find all the values between 0 and 2 pi where the tan of 2t is undefined, okay, where the tangent of an angle is undefined. And we know the tan curve is undefined at pi over 2. Okay, the tan curve looks something like this. It has asymptote at pi over 2, which is 90 degrees, and then also at 3 pi over 2. Okay, at 3 pi over 2. That's going to be, sorry, that's going to be 90. Let's do it properly. You have the tan curve will look something like this, and then it will look something like this. Okay, and then it will have this bit at the end. All right, so this is 90 degrees, and that's 270, so that's pi over 2 and 3 pi over 2. So at pi over 2 and 3 pi over 2, the tan curve is undefined, okay, as we should know from its curve. So we can say that 2t is equal to pi over 2 and 3 pi over 2. Those are the two places where the tan curve is undefined. That means when t is equal to pi over 4 and 3 pi over 4. Okay, so it says here, find the coordinates of the points. So there's more than one point, as we can see here. So now we know what the t values are. We can find the coordinates of the points by using the x and y parts of the parametric equation. So we can say when t equals a quarter pi, which is pi over 4, then x equals 3 times, remember this is cosine of pi over 4 squared. That's what it means. Remember, cosine squared of something. So cosine of pi over 4 squared, that's 3 times. Now the cosine of pi over 4 is equal to 1. Cosine of 45, is equal to root 2 over 2. That's the tan. Cosine of pi over 4 is root 2 over 2. So that's root 2 over 2 squared. So that gives you 3 times 2 over 4. That's 3 times 2 over 4, which gives you 6 over 4, which is 3 over 2, basically. So that's the x-coordinate when t equals a quarter, and where y is equal to the sine of 2 times pi over 4, which is equal to the sine of pi over 2, and we know that's equal to 1. So when t equals pi over 4, we're on the point 3 over 2 and 1. So that's one place where the gradient of that curve is equal to 0. And when t equals 3 pi over 4 is the other value, 3 pi over 4. So we have x equals 3 times the cosine of 3 pi over 4 all squared. Now 3 pi over 4 gives you the same as root 2 over 2, but this negative because it's in the second quadrant. So this is going to give you 3 times, it'll be the same thing because you're going to have to square it. So it's 3 times negative root 2 over 2, but squared is going to give you the same value, 3 over 2. That will be 3 over 2. Okay, that's the x-coordinate. And the y-coordinate will be when you have the sine of 2 times negative 3 pi, 2 times 3 pi over 4 am I talking about, which is going to be the same as the sine of, this is going to be 3 pi over 2. Now the sine of 3 pi over 2 is going to be negative 1. Okay, it's negative 1. So the other coordinate is when t equals 3 pi over 4, then the other coordinate is going to be x is 3 over 2 and y is minus 1. So those are the two places where the curve has a gradient of 0. Okay, so there's the answer to part B of this question. The 2 points where the gradient of the curve is equal to 0. Okay, which means if the gradient is 0, that's where they're parallel to the x-axis. Okay, so you can say that those are the two answers. If you want to make it clear in the end, okay, so you can say that answers, just put it here clearly, are 3 over 2 and 1, and also 3 over 2 and minus 1. Of course, you don't really use highlighters in the exam. That's just for the purpose of showing you. Okay, so there's the answer to part B of the. Now for part C. Now in this question here, again, it doesn't depend on part A or even part B. So it's independent of those because you already have dy dt, dy dx here. So we can use these given values to answer this question. So again, another 3 marks. If you didn't know how to do part A, don't ever give up a question. Always continue and try to see if you can answer the rest of it. So here it says, show that the tangent to the curve at the point where t equals pi over 6 has this equation, 2x plus 3 root 3y equals 9. Okay, so now, the tangent to a curve. Now, the tangent to a curve is basically a straight line. Okay, it's a straight line which has the same gradient of the curve at the point at which it touches the curve. Right, so that would be a point, for example, where this line is a tangent to this curve. I'm not saying this is the same curve that we have here. I'm just giving you an example. That's a tangent to a curve. So to find the equation of a tangent, it's basically finding the equation of a straight line, which requires two pieces of information. The first piece of information we require is the gradient of the tangent. Okay, the gradient of the tangent. And the second point is we need to find is any point on the line. The coordinates of any point on the line. If we find the coordinates of any point on the line, we have found enough information now with the gradient to find the equation of the line, because we can use the formula y minus y1 equals m times x minus x1. So we need to have a point x1 and y1, and we need to have the gradient of the tangent, and that will give us the equation of the straight line. So both of those things can be easily found in this question by using what they gave us. We can find the coordinates of the grade of the tangent. We can find the value of the tangent at the point where t equals pi over 6. So we can say when t equals pi over 6, we can say the gradient of the curve, the gradient of the tangent is going to be equal to, replacing this into the formula, minus 2 over 3 times cotangent of 2 times pi over 6. Okay, which is minus 2 over 3, and this is going to be times 1 over, this is going to be basically 1 over the tan of pi over 3. Okay, because 2 pi over 6 is pi over 3, and that gives you root 3. So that's minus 2 over 3 times root 3. Okay, tan of pi over 3 is root 3. Okay, so minus 2 over 3 root 3. If you want to write that in its rationalized form, we can. Just leave it like that for now and see how it works out in the equation. In the end, we'll rationalize everything if we have to. So it's minus 2 over 3 root 3. That's the tangent. Okay, so that's one thing that we need. The second thing we need is a point on the line. So we can find that because we know the x and y values, or the equations in terms of t for x and y. So when t equals pi over 6, we can say x is going to be 3 times cosine squared t. Remember, that means cosine of t, which is pi over 6 squared. Okay, so the cosine of pi over 6 is equal to, that's 30 degrees, so that's equal to root 3 over 2. Okay, so that's 3 times, and that's going to be root 3 over 2 all squared, which is 3 times 3 over 4, which is 9 over 4. And the y coordinate is going to be equal to, if we take the sine of 2t, so that's the sine of 2 times pi over 6, which is the sine of pi over 3. Okay, the sine of 60 degrees is root 3 over 2 as well. Okay, that's root 3 over 2. Okay, because this is 60 degrees. So the y coordinate is root 3 over 2. So we can say here that the coordinate of the point P, that we call P here, is going to be 9 over 4 and root 3 over 2. So now we can go on to find the equation of the line. So we can use this gradient and this point here. We know the gradient of the tangent, as we said, was minus 2 over 3 root 3. I'll leave it in this form for now, and we'll see how that works out. So we have y minus y1 equals m times x minus x1. Let's put those values in now and see what happens. So we're going to have y minus y1, which is root 3 over 2, equals m, which is minus 2 over 3 root 3, times x minus x1, which is 9 over 4. Okay, remember, our equation has to look like this in the end. Okay, so I'm just going to take that down. Okay, so our equation has to look like this in the end. We have to make this become that, basically. We have to show that this is the equation. Now, what I can do first is, let's get rid of the fraction, the 3 root 3. Okay, let's get rid of the 3 root 3 first. Let's multiply both sides by 3 root 3, in which case you're going to have 3 times y times root 3 minus, this will be 3 times, this will be 3 root 3 times root 3. Okay, 3 root 3 times root 3 over 2. I'll just leave it like that for now. Okay, 3 root 3 times root 3 over 2. And this will be equals minus 2 times x minus 9 over plus 9 over 2. Multiplying both sides, multiplying this, expanding this bracket, minus 2x and plus 9 over 2. Okay, so this gives you here 3y times root 3 minus, this is 3 times 3, which is 9 over 2, equals minus 2x plus 9 over 2. And now what we can do is make it look like this. So we could, we could add 2x to both sides because the 2x has to be positive. Okay, and we already have here 3, this is the same as that, this is 3 root 3y, so it looks like we've got there now, 3 root 3 times y, and you have minus 9 over 2, minus another 9 over 2. Okay, so you have minus 9 over 2, and then you have minus another 9 over 2. In fact, we want to put it on that side, it says equals, so yeah, let's just keep the this 9 over 2 over here, so we have 9 over 2 plus another 9 over 2. Okay, and of course that gives you 9, all right, because that's 18 over 2, which is 9. Okay, so that's going to be exactly as we have to show. So therefore we can say we found 2x plus 3 times root 3y is equal to 9, and we've shown exactly what we have to show to answer part C of this question. Okay, now part D of the question is find a Cartesian equation for the curve in the form y squared equals f of x. So this is now where we want to combine this together into one equation and eliminate the t. Now whenever you have a equation which involves parametrics and trig identities and trig functions, and you want to find a Cartesian equation, it's always going to have something to do with the identities that we know. Okay, and the main identities we know, two main ones, are sine squared of an angle plus cosine squared of the same angle is equal to 1. That's the main identity that it looks like we're going to have to use to make this into one equation. So what I'm going to do is I'm going to express cosine t and sine t, okay, in terms of x and y, and then I will try to use this identity to rewrite them. Okay, so first of all, this is y equals sine 2t. So let me first of all write this as y equals 2 times sine t times the cosine of t. And I know that x equals 3 cosine squared t, so I'll write x, x equals 3 times cosine squared t. So what I'm going to do is I'm going to make cosine squared t the subject. So cosine squared t is equal to x over 3. So I've made that the subject. So what I can do now is I can replace this with x over 3 squared. All right. Now I'm going to have to put something over here in terms of sine t. Okay. So we know that. Let me write this. Let me write this down here so that's clearer. Let me just. So basically, I know what to put in place of that. Okay. I'll put it down here afterwards. Now, next we can think about the y. All right. I know y equals sine 2t, so y equals sine 2t cosine t. All right. So now, I know that from this, I know that the sine squared of t plus the cosine squared of t equals 1. I can find an expression for the sine of t in terms of x because of this. So I know that the sine squared t is 1 minus cosine squared t. Right? So I can write sine squared t as 1 minus x over 3. If cosine squared t is x over 3, then sine squared t is 1 minus x over 3. So that's what I can write in terms of sine squared t. Now it says, find a Cartesian equation for the curve in the form y squared equals f of x. So now what I can do is I can take this, I can say, let's say that means y squared is equal to 4 times sine squared t times cosine squared t. Okay, y squared, because we want to write it in the form of y squared. And I have an expression for cosine squared t in terms of x, and I have an expression for sine squared t also in terms of x. So I can now replace the sine squared t and the cosine squared t with what they are in terms of x, and I've got an expression for y squared. So y squared equals 4 times this, which is 1 minus x over 3, times cosine squared t, which is x over 3. Okay, so if I just now expand this, I have 4 minus, that's going to be 4, sorry, let me just do that properly. Okay, let me do that properly. That's going to be 4x over 3 times 1 minus x over 3, okay, which gives you y squared is equal to 4x over 3 minus 4x squared over 9. You can leave it like this if you want, that's fine. Okay, you can leave it like that. You can write it, factorize, but that's absolutely fine. They didn't tell you how to express it, but something like that is perfectly good. Okay, you could leave it factorized like this, or you could take out, write it as over 9 and so on, but that's fine. You don't have to put it in any particular way. You don't have to write it as one fraction. That's fine. So any form that gives you this. So for example, if you wanted to write that as one fraction, you could write this as, you have to multiply, so you could write this as 12x minus 4x squared, okay, over 9. Okay, that would be the same as 4x over 3 minus 4x squared over 9. Yeah, you could write it like this if you want to. However you wish to write it, you can write it. But that's perfectly fine. This is a perfectly fine way of writing your answer. So we have basically written a Cartesian equation. What does it mean by Cartesian equation? You just have to have y in terms of some function of x, as they mentioned here. So you're going to have to eliminate the t from the equations. All right? And this is how you do it. You always try to link them together using the identities. So that's how I found cosine squared t is x over 3, and I know that sine squared t is 1 minus x over 3. So I use the double angle formula to split this into two parts, sine t and cosine t, express them as single angles, and then they want y squared, so you square that, you get 4 sine squared t cosine squared t, and then substitute what you have your expressions for cosine squared t taken from this, and sine squared t taken from the fact that 1 minus cosine squared t is the same as sine squared t, right? And that's the answer to this question. I hope that was clear. Thank you for watching, and that completes the whole of this question from A to D. Again, thanks for watching. Other questions from this particular paper, Solomon D, should be found in the playlist that will appear over here. I do them by request, so if it hasn't been requested, it hasn't been answered. So whatever have been requested, you'll find in that playlist. Other questions from the end of topic worksheet number 3 on parametric equations can be found in the playlist in this region over here. Other questions about parametric equations from P4 in general can be found in the playlist over here. And you can subscribe to my channel by clicking on the link that's going to appear in this region. Thank you for watching, and see you soon.